So good afternoon, ladies and gentlemen. Good evening to my South Asian friends and good morning to my European friends. I welcome you all for today's e-conference on empowering engineers with advanced analytics, organized by Indian Chemical News and Trend Miner, a software AG company. Just a brief about Indian Chemical News. Indian Chemical News is a new age media platform which provides a complete 360-degree view on the chemical sector, both local as well as global. The new age media disseminates information through to industry stakeholders through multiple platforms, news portal, research reports, e-conferences, industry reports, and others. The portal focuses on chemicals, petrochemicals, pharmaceuticals, and energy sector through news, views, trends, analysis, technology updates, interviews, and columns. Myself, Praveen Prashant, editor, Indian Chemical News, will be your host and moderator for today's e-conference. The presenting partner for today's e-conference is Trend Miner, a software AG company. The company's platform has been adopted by large process manufacturing companies, and the company is planning to expand its business in India. Over 1,000 software AG employees work in India, and the company has a partner network for local support. The speaker for today's e-conference is Ms. Ruchika Tawani, Data Analytics Engineer at Trend Miner. Ruchika is a chemical engineer with specialization in process systems engineering. She has led more than 25 projects at leading chemical companies, working directly with plant engineers to help them derive useful insights from their data and optimize processes, leading the digitization journey to success. The topics that we are covering, or the topics that Ruchika is covering, is doing more with data, what is self-service analytics, what is Trend Miner, who is using Trend Miner, use case demo, batch analytics, continuous analytics, asset analytics, predictive analytics, and benefits for the chemical industry. Next slide. Next slide. So the upcoming events that we do have, on May 11, we have Unlocking Lab Efficiency Through Digital Transformation. On May 18, we have Indian Specialty Chemicals Opportunities Galore. And on May 21, we have Green Chemistry and Sustainability Challenges and Opportunities. Next slide. Just a brief on ICN Play and Win contest. Let me brief you about the contest. The moderators, will be asking questions from the delegates during the course of the session, and the one who responds first with the correct answer stands eligible for winning ₹1,000 voucher from Amazon. So request you to carefully listen to the presentation by Ruchika Tawani. All the questions will be asked by the moderator of the session, and the replies need to be given in the chat window. So I would request all of you to give your replies in the chat window and not on the Q&A window of your respective screen on Zoom platform. Final winners will be announced at the close of the e-conference session today. The terms and conditions: only the person with the correct answer responding first in order of priority shall be declared winner. Organizer and sponsor partner employees are not eligible to participate in the contest. Organizer decision to be treated as final in case of any discrepancies. Gift vouchers to be sent electronically to all the winners post completion of the session. Now, on behalf of ICN, I will request, next slide. On behalf of ICN, I would request Ms. Ruchika Tawani to give her presentation. And then after the presentation, we will open it up for quiz and then follow it up with the Q&A at the end of the presentation. So I would request Ms. Ruchika Tawani, Data Analytics Engineer at Trend Miner, to give her presentation. So over to Ruchika Tawani.
Thank you, Mr. Prashant. Let me just start by sharing my screen. All right, so first of all, thank you for the opportunity for me as well as for Trend Miner to present today in front of this audience. Now, we already took a brief look at the agenda, but just to quickly go over it again, what I would be presenting today is first a bit of about Trendminer, what is the company about, what is the software about, then diving a bit more deeper into doing more with data. So how we as the chemical industry, how we as chemical engineers, chemical process industry can we utilize our data more. So there we come to self-service analytics. And we also have a few use cases, examples here in front of you. So we try to divide the examples that we have in terms of the solution areas, which are batch, continuous, or asset analytics. So a few of the examples I will be showing live as a demonstration, but since for the sake of time, we have to keep it short. So we also have a few other examples in the slides as well that cannot be presented immediately. So starting with Trendminer, what is the company about? What do we do? So the company started in 2008 with a different name back then, which was D Square. That was back then started in Belgium. So it's a spin-off from KU Leuven, which is a university in Belgium, as well as Bayer Material Sciences, which is now Covestro. So they started the company as more of a data consulting firm, and as they worked with more and more customers, they realized the need for a product or a software like Trendminer. And so the first version of the software was developed and released around 2015. So since then, the company has been, we have been growing exponentially. We have been gaining more and more customers, more and more people who have been realizing the potential of Trendminer. And again, the headquarters of the company are in Hasselt, Belgium, but we also have offices, for instance, in US or even all over Europe. So for instance, in Germany, Spain, Netherlands, and a few other regional offices as well. So the most recent developments for the company have been the acquisition by Software AG in the year 2018, which is Software AG is a huge German software company, and they have been in the business for more than 50 years. And lastly, on the Trendminer side, we have, as I mentioned earlier, we have been growing a lot. So as of today, we have more than 100 customers worldwide. And across all of these customers, we have more than 1,000 plants connected to Trendminer using the software already. All right, so what is the software about? What is the philosophy? So our motto at Trendminer is data science for non-data scientists. So we want to provide an advanced analytics solution, a software platform to the process experts where they can use their data that they have already been collecting to analyze, monitor, and predict their process performance within the operational context. And as I mentioned earlier, a lot of the bigger chemical companies worldwide have already been using this software for quite some time. So as of today, we have 45% of the top 50 chemical companies in the world are already Trendminer customers. So you see some of the names here, for instance, from the chemical companies, but we'll come back to it later on in the presentation, where you'll see that it's not just present in the chemical vertical, but also in other verticals like oil and gas, pharma, and so on. So moving on, just trying to highlight a few of the common challenges that we as the chemical industry face when it comes to talking about data, when it comes to utilizing data for analytics. So the first thing is to leverage the production data and craftsmanship. Now, if we look back a few years, back then, the discussion or the problem used to be, how do we collect more data or how do we store more data into our systems? Right now, we have advanced a lot, and now the problem is it isn't anymore about just collecting and trying to gather and accumulate that data. Rather, we have those huge data sources, the big data, and now it's just about how can we leverage this data? How can we use this data to gain insights from it rather than just have it sit in some server? Then the next challenge that we also face when we talk about data analytics, big data, the immediate thought for anyone would be that we need a person like a data scientist to actually help us analyze that data. But the problem with data that data scientists often face while working with such data sets is that they do not have enough context of what the data means. So the story that the data tells, it's actually more clear to someone who works with this data or with this plant on an everyday basis, which is the process knowledge. And that is a bit lacking for data scientists. The next thing is the time factor. So any problems that we have, any use cases that we want to tackle with our data, we want immediate solutions, we want immediate results. So for instance, here we see on the slide that there is, for example, a leak in the plant. And if such a leak happens, we want to be able to react immediately so that we can take some preventive measures to avoid problems from happening. So we do not want to wait a long time to send this data to someone to analyze and then get back the results and then try to do something. And the final thing that I also wanted to highlight was the improvement potential. Now, at a lot of companies and a lot of our customers that we see, there are already quite a lot of initiatives around process optimization, around improving the existing processes, around increasing the KPIs. But a lot of the data that we already have in store holds a lot of potential. You can easily gather a lot of quick wins just by looking at the data, just by gaining some insights from the data. But how to do it is still a bit of a problem when it comes to putting that data into practice. So the usual route to get more insights from your data, there are usually three factors that we have. So the first one is the existing tools that we have. So for example, I am a chemical engineer, I am a process engineer. If I am asked to analyze a data set, my typical approach would be, maybe I have a historian that is storing the data, or the DCI system. So I get the data out of that system, I export it to Excel, and then I try to work further with it inside this Excel file. But that's actually not very effective, because Excel is not really meant to handle such huge quantities of data that we're talking about. And also it often takes a lot of, let's say, programming, a lot of customization from the user side to actually get some insights out of this data based on the existing tools that we have. So that's one factor that we need to look at. Another thing is the data scientist factor. So as I mentioned earlier, the problem is that we need a data scientists to look at the data, but the problem is that there are not enough data scientists in the field, because it's a very new and upcoming field. So it's a challenge for companies to hire the right talent, definitely. But even if you do hire the right talent, it's usually one of the central groups in your company who are working with maybe all of the plants that you have. So it's their only job to work on one plant or to work on one particular stream of process. Rather, they're actually continuously working with a lot of different people with a lot of different use cases. So it's often difficult to realize some quick value, some quick insights. And finally, the data infrastructure. So a lot of times we see at our customers, the problem is that our customers tell us that we cannot yet start doing analytics, or we cannot yet start using the data, because we still need to put a central data infrastructure in place. We are only storing it in one place, but we need to first modify all our infrastructure, and only then we can start analyzing it. But that's also kind of a wrong thinking, because if you already have the data in place, if you already have the data sitting somewhere, you should already be using that data. So that's where the trend miner ideology comes into place, that we want to democratize industrial analytics. So we want to empower everybody who can actually make use of the data, or who can make sense of the data. So that could be the process engineers, that could be the operators, that could be plant managers, anyone who can understand and use the data effectively. And when do we need to do it? We should not wait until we have an entire infrastructure in place. Rather, we should be starting today, and with the data that we already have. Now, this ideology, this philosophy has also very well been identified by our existing customers. So for instance, I have the example of one of our users here from Total Refinery. And he says that we need to, and he also rightly identified it, where he says that we need to give the power of the data to the people who can interpret this data. And for him, or for his company, TrendMiner provides a user-friendly self-service analytics tool that can give a lot of time savings and deliver better results than data models. So what is the Trend Miner solution all about? So for us at Trend Miner, as part of our solution, we have the users as the central part of the solution using the Trend Miner analytics platform. And in the analytics platform, we gather data from two different sources, or rather two different kinds of data, you could say. On the one side, we have the time series data, which is the more common form of, for instance, sensor data. So if you're measuring temperatures, pressures, any other parameters in your plant which are being continuously measured with timestamps, so that is called time series data. And on the one side, we connect to this time series data. And on the other side, we have the contextual data. So contextual data is what gives the time series data a bit more context or a bit more information. So that could be in very loose terms, we call it event data. So for instance, that could be your shift logbook, the shift handovers that tell you which were the most critical parameters that happened in the last shift. Or that could be, for instance, an SAP system where you're already storing all your maintenance information. Or even one of the more common ones is also a limb system. So the lab data or the quality measurements that are being performed in the lab are usually not stored inside of the historian or inside of the DCS or the time series data. And that's usually a separate system in the limb system. And you could also connect that as part of the contextual data connection. So once we have these two kinds of data in place, or these two kinds of connections in place, we can leverage both of them to derive some insights, to do some analysis. And finally, for the user, is also very nice, very user friendly to have a dashboard of only the most important KPIs, only the most important things that I as a user need to keep an eye on. All right. So of course, there's no single way to finding the solution or to finding the right path in Trend Miner, but just to kind of concretize a bit, what am I talking about? What is analyze, monitor, and predict means? I have a very simple example of how we could go about a use case when we try to tackle it with a software like Trend Miner. So the first steps are, of course, always to define your situation, to define which data you need, to define what has happened. And once you have that defined, we at Trend Miner always advise to do the second step, which is a very powerful step, which is the question, to answer the question, has it happened before? Because if it has happened before, then maybe you could gain more insights from those historical time periods as well, where this situation has happened. So in Trend Miner, this is also actually, by the way, a very powerful functionality, which is what we call a search functionality, that within a matter of seconds, you can actually search through years and years of historical data for a defined process, for a defined process operating zone, or for a defined process region that you want to search for. So the second step about has it happened before. And finally, Trend Miner also helps you to identify a root cause if there is a problem that is happening more and more frequently. So there are tools, or there are features to do some correlation analysis, but there are also features to just do a comparison between good and bad time periods, for instance. Then once you have identified your root cause, once you've identified your problem, it's also very easily possible to let Trend Miner monitor this problem with you for you in the future with the help of fingerprints. We would be looking at what fingerprints are at a detailed in a later example. But Trend Miner would then basically look at the process, monitor the process for you. And once the monitor is set up, as a Trend Miner monitor would always be active, always trying to look at the process to see if there are any problems. You might be able to get early warnings, early predictions of early warnings if there is a problem about to happen in the process. And those warnings are basically led to the key stakeholders who need to know about these problems via, for example, email messages or just via the platform in general itself. Finally, we also have the possibility, once we have gone through this entire workflow, we have set up everything in place, we also recommend, and we also have the possibility to contextualize all of this information, to summarize all of this information in terms of an event inside of TrendMiner itself, so that the next time you work with this data set, you already have this contextual information as well, that there was a problem because of this particular root cause that you found. And finally, as I mentioned earlier, all of this comes together in the form of a dashboard where you can keep an eye on your most important KPIs, most important parameters. So yeah, as I mentioned, it's a very diverse software. So we have customers with very different kinds of processes in place. So definitely customers from batch analytics, but also customers from continuous plants, or even a lot of customers use TrendMiner to do some asset analytics, for instance, on their heat exchangers or pumps, for example, to predict fouling, which would be one of the use cases we will be looking at later on. So let's start with the demonstration and the use cases. So the first one that we'll take a look at is the batch process, the batch analytics. And just to give you a brief overview of what we will be looking at here, the problem description. So we're looking at a polymer production process where we have different grades of product being produced. So we have food grade product, industrial grade, and pharma grade. And we see that during the production of the pharma product, we have had some off-spec batches. So this definitely, of course, leads to production losses. And we want to try to combine our lab data, because that tells us what our quality is. So we want to combine our lab data with the sensor data to do a detailed analysis on these failed batches, on these failed products. And we want to try to determine why this might have happened to our product. So to do that, I will, as I said, I will be demonstrating it live. So I have now changed to TrendMiner, and in here at first we have this dash hub interface. So here I have a dashboard of my process, which is called the Powder Pro process. It's this polymer process. And here I have a 4-week overview of the process. So what do I see? The first thing is, of course, the trends, the most recent trends. Here I have the last 8 hours, just to keep an eye on what is happening in the process. But I also have more summarized batch information for these 4 weeks. So in 4 weeks, we produced a total of 121 batches, and we had 2 failed batches. At the bottom, we also have a breakdown of a grade-wise breakdown of these batches. How many of pharma batches did we produce? How many food batches and industrial batches? So as I said, we will be analyzing the pharma batches in this case. So as I mentioned earlier, we had some rejected pharma batches. So in this case, these are these 2 batches, as well as the second tile, or the second number is showing me just the golden batches for this pharma product. So golden batches meaning batches that have run exceptionally good. So these are our ideal batch runs, and we always want our batches to run like this. So in this case, I want to go ahead and analyze this rejected pharma batches to see why they were rejected. So let's click on that, and that would take us to Context Hub, where we see a bit more detailed information for each of these batches individually. So for example, here the first one, it's just telling me that this was a batch in the Powder Pro process, but we also have some other information like when did it start, in which reactor was it being produced, or even the batch ID, the grade, and some other lab data that we are measuring on this batch. So for example, if I click on this one, I also see all of the information that is stored there. So here it also says that this is coming from the LIM system. So we have a direct connection to the LIM system in this case. And yeah, so the assay, molecular weight, color, these are all quantities that are stored in the LIM system for this particular batch. What we also see here is, for example, we also have a total duration of the batch. So the start and end date used to calculate the total duration, which is about 16 hours. That can also be useful in a lot of analysis for such batch processes. Now, regarding these failed batches, why we are calling them failed is because, I can quickly show you, here we have a viscosity measurement, and any batch that has a viscosity lower than 50 would qualify as a failed batch because this is the product that we cannot sell to our customers. So the viscosity is the main reason why this batch is a failed batch, is an off-spec batch. So let's now try to go ahead and try to analyze why the viscosity was lower. So for that, I will go to the options and click on visualize. And when I do that, Trend Miner will take me to, so for this particular batch, Trend Miner will take me to the trend side where I can see and select which sensor measurements do I want to check for this batch. So in this case, let me just select all 5 of these measurements for this reactor. So there's, for example, the temperature, feed rate, the overhead pressure, and all of the measurements related to this particular reactor. So now I have these 5 measurements in this 16-hour time period displayed on my screen. And I just wanted to know, why was this an off-spec batch? What was the problem? If you remember, we also had here, for example, these 11 golden batches. So this golden batch information we also have in Context Hub, which is basically stored under this view here, under this list. And what we can do now, because we know that if you look at it, the viscosity is also quite high. So because we know that these were extremely good batches, we'll try to use these batches as a benchmark to compare with our failed batches and try to identify if there were any differences. Now, I've already prepared this a bit because for the sake of time, we cannot go into too much details. But what I've done is, using these golden batches, I've created a fingerprint. So let me open up that fingerprint for you first. Yeah. So this is the fingerprint for the pharma golden batches, and I'm going to add that to the view. And when I do that, you might see that, for example, this is here our fingerprint, and which is basically just this colored region, this colored envelope that we see for each of these tags separately. So this represents that my process, my parameters should always be running inside this colored region, inside this envelope, for it to eventually give me a golden batch viscosity, or eventually give me a very high viscosity. So I can use this as a reference or as a benchmark to compare my off-spec batch and to see what the difference was. So when we do that, when we did that, we saw that there is this one parameter called the overhead pressure, which actually shows some deviation. So the first thing is, there are some oscillations here at the beginning, while the golden batch was a pretty straight, constant temperature pressure. So that could be one of the reasons. But what's more important here is, if you look here at the bottom, the lowest point in the temperature, or this dip in the pressure, sorry, this dip in the pressure, it's in the bad batch, which is this solid line. It's not going as down as it was in our reference case, which is this envelope. So that could actually lead to some differences in our process. So just to give you a bit of a background, what is actually happening in the process is that we are using vacuum in the process to distill off our monomers. Now, since we do not achieve such a lower pressure in this off-spec batch, we are not able to probably remove all of the monomers from our system, and that could eventually leave off some of the monomers still in the product, which are reducing the viscosity of the product. So that's a very likely cause why we have this off-spec behavior, this off-spec batch. So that's the overhead pressure could be one cause. And in order to avoid this from happening again in the future, in order to avoid overlooking such a situation in the future, what I can also do is, now that I already have my fingerprint, I can just go to the monitoring menu, and this is the fingerprint that I have, and I can tell Trend Miner to detect for deviations from this fingerprint. So every time our pharma batch is being produced, Trend Miner will keep an eye on this fingerprint and see if the process is deviating from this fingerprint. If it is, we would automatically get alerted via an email message, for instance. And then the advantage is that then I, as an engineer, do not need to keep a constant eye on my trends on my computer. Rather, Trend Miner is doing that on the server in the background and sending me an alert if that happens. So just to summarize it a bit, what we did was we used contextual data, so lab data, to identify the off-spec batches. And we also fingerprinted the good quality batches to use it as a benchmark. So the final problem that was identified was in our vacuum system. And we also activated, and this reactor, this temperature that we are working with is actually, the product is actually quite temperature sensitive. And if the reactor temperature increases, it could have a bad effect on our product quality. So we want to determine if this spike has happened before, and we want to determine the cause of this. So going back to my trend hub, I had also created a dashboard for this process. So in this case, we see a bit more information here actually. So we see, for instance, there are there's some information about the number of quality deviations we had in the last 1 month. Apart from the trends, of course, the trends are definitely there. And we also see here at the bottom, so in the previous example, we talked about monitors, Trend Miner trying to automatically keep an eye on the process. So in this case also, I have set up some monitors on this reactor 102 that I'm working with. And here I also see the live status of all of these monitors. So for instance, I see that the pressure difference and the inlet flow seems fine right now, but the reactor temperature has a problem. So let's go ahead and try to analyze this reactor temperature. And all right, so let me just remove these other tags. Okay, so now I have the reactor temperature on my screen. And as I said, we want to try to first also answer the question, has it happened before, or is this just a one-time occurrence that we have in the process? So to do that, I'm going to use the search functionality. And the search functionality, as the name suggests, it's just a possibility for you to dive into the historical data and to find certain patterns or certain behaviors of the process. So for instance, in this case, what I'm going to do is I'm going to take this entire, so what I'm seeing here is 1 hour of data on the 1st of May. So I'm going to use this entire 1 hour window as my initial pattern. And I'm going to try to ask Trend Miner to do a pattern recognition on this time period to try to identify similar occurrences in the historical data, wherever that might be. So that can be done with a similarity search. And maybe I will just, so this minimum score is just the matching score of the results that we'll be getting. So let me just increase that to 70. And what I will also do along with that is just to select this peak and to give it a bit more weightage. So that would mean essentially that we are looking for such time periods where we had a stable operation, no known problems, and then suddenly the temperature started rising. But also this rise in temperature has much more weightage in this pattern recognition compared to this constant time period. So I will do the search here. And what I find is 6 results on these dates that are mentioned at in the list. So one thing I could do is so here I have the data from the 1st of May. If I want to check what was the result on the 8th of March, what was happening there, I can just directly click there and Trend Miner takes me to that time period. So on the 8th of March, we see that again, it's a bit of a similar behavior. We can also check that for the other results. But what might make more sense in a situation like this is if we just go back one step. So I'm back with my original time period. And instead of visualizing them one by one, I'm going to add them to my view that I already have. So that means I clicked on this plus sign, and with that, I actually added this second dashed line to my view. So what do we see now? Just for clarity purposes, the solid line is the temperature on the 1st of May, where we had this peak. And the dashed line is the search result that Trend Miner found and thinks is similar to the 1st of May, which is on the 8th of March. So we see that actually it was indeed quite similar, and the peak was actually going even higher than what we had in May. So we can do the same exercise with the other search results as well. So just to try to compare if the results even make sense. So in this case, all of these actually are either the same height or even higher temperature than what we had in our initial case. So that answers our second question. It does happen pretty frequently. It seems to be a problem in the process. And now can we ask TrendMiner to help us identify the root cause? So to do that, I will use this light bulb functionality, which is called the recommendation engine. And the recommendation engine will try to take all of these 6-7 instances that we have put up on our screen and try to see if there is a correlation between the reactor temperature and any other parameters that we have been measuring, that we have been storing. And in this case, we find 3 results. So this is the search is, by the way, a global search. It would search across all of the DCS parameters, all of the sensor measurements that you have actually saved in your system. And in these 3 results that we have, we actually see that, for example, here, there are 2 related to the cooling water. So maybe there's something going on with the cooling water temperature. So the cooling water temperature is an 80% correlation, and it's also an early indicator. So what does that mean? Let's add that. Right? Yeah. So the cooling water temperature is basically the green one that just got added now. So just to make it maybe a bit more clear, let me put it like this. So for each of the lines, the red lines are all representing the reactor temperature in different time periods. And for each red line, we have a corresponding green line. So for each reactor temperature, we have a corresponding cooling water temperature over here. So we see that, for example, if you look closely, you would instantly notice that the cooling water temperature always has a peak in this time period, around this time. And then after about 6-7 minutes, our reactor temperature starts rising, which also makes sense from a process point of view, that if the cooling water temperature increased, you're not providing enough cooling to our reactor. And that's probably why our reactor temperature also started increasing. So that gives me the hint that I need to go and look into my cooling system. Maybe I need to look into the valves that are in my cooling system and try to identify why this problem over here was happening. All right, to summarize it again, what are the results that we found? We found that the spikes occur very frequently. We used the pattern recognition features to identify similar events. And finally, the correlation analysis revealed a rise in the cooling water temperature. All right, now looking at other use cases that one could tackle with a tool like TrendMiner is, for example, in terms of asset analytics, we said. So in terms of asset analytics, we have done this one use case for one of our customers, where it's also about actually a polymer production process, where we have consequent heating and cooling phases. So the cooling phase is very important in this process because it's a bit time consuming, but also because if the heat exchanger is fouled, the cooling takes a lot of time, and that means we are losing a lot of production time. So what we wanted to do in this case was to monitor the fouling for the production of different products, and to try to identify when we need to schedule maintenance. Because if we schedule maintenance too early, it would lead to a lot of downtime, but also if it's too late, our performance of the process is not that good. So what the solution that we came up with was, we did some calculations in the software in TrendMiner itself, and at the end we decided to set a monitor on the cooling time for every product. For every product we are producing, we calculated the cooling time, and if the cooling time starts to increase the value that we be expecting, a warning is sent out to the engineers that maybe we need to watch out for fouling in the heat exchanger. So this was actually done very quickly, very easily inside of TrendMiner, but it also had, a lot of huge benefit for the customer. So for instance, the predictive maintenance helped them to do more production runs, to reduce maintenance costs, but also to reduce safety risks. And all in all, to quantify it, we spent only about an hour doing this use case, but at the end, it resulted in a 1% increase in the revenue of the production line just by doing this simple calculation. So some of the other use cases, some of the other examples that I can also highlight at this point are, for example, for batch analytics, very common use case is cycle time reduction to reduce the runtime of your batches, fingerprinting of batches, so real-time monitoring and prediction of batches, but also in other areas. So continuous processing, a very common thing to do is to use soft sensors, to create soft sensors to predict quality, to reduce energy consumption, to do some process optimization. But also on the asset side, we already saw the heat exchanger fouling, but also the same thing for pumps you could do. But also very important is to improve the asset performance by defining some good operating zones in the process, or some best operating zones. Now, all of this coming from me maybe does not mean that much, but it's also the same thing that our customers actually tell us, that the process data tells stories and all we need to do is to capture them. So TrendMiner, in this case for Covestro, TrendMiner enabled them to bring the process information within the data by using annotations and to maximize knowledge transfer, bringing innovation. All right, so I mentioned earlier that we already saw some of the names that we have in the chemical industries, but also to highlight that it's not the only industry that we work with. Of course, it's our main sector, it's our home, but we also have a lot of customers, for example, in oil and gas, or in the energy sector, or in the food and beverages sector, or for instance, in pharma. Pfizer is a name that we keep hearing very often these days because of all the vaccines. So they're also one of the biggest TrendMiner customers. And before, so wrapping up, just one more thing that I would also like to say to summarize this all. So what are the benefits that TrendMiner, or just in general self-service analytics, could bring to you or to your company? So the benefits lie not just in analyzing data faster, but also in increasing the efficiency of your resources that are working with the data. So by that, I mean the process experts, the process engineers, the plant managers who are actually taking care of these kind of problems on an everyday basis. A self-service analytics or a tool like TrendMiner can help them do their job more efficiently, or to implement such improvements faster. Then you could, of course, definitely analyze process behavior. So a lot of times when you want to make some changes to your process, you need to provide some solid reasoning for that, and it cannot be just based on feeling. So such impact analysis and hypothesis testing can be very easy, leading to better conclusions and project justifications. Root causes, you can find root causes fast. We already saw a few examples of that. You can also drive operational performance. So optimizing processes, leading to decreased cost, leading to more revenue, or just to control the quality of your products. And finally, to increase company-wide collaboration. So TrendMiner is a tool that can actually be used just company-wide. It doesn't have to be stored or centered locally at one of the sites, at one of the plants, but it can be used by multiple people together across various sites. You can collaborate with your colleagues in other plants, but also in other countries, in other sectors of the company. So having said that, why do we think that TrendMiner as a solution could help you? There are several reasons for that. So the first thing is definitely our software. It's a data analytics solution, but it's actually specifically designed and developed for the process industry. All of our customers are in the process industry. And it's a plug and play software, so you do not need an extra separate installation for every user, for every person that wants to use it. Rather, it's just one central installation, and it's very easy to set it up. And it's very intuitive user interface. And also, the one thing that I personally like a lot about TrendMiner is that the algorithms that we have, I, as a user, do not have to write those data mining algorithms myself, or the data processing algorithms. Rather, TrendMiner does that for you in the background. You just need to provide TrendMiner with the problem that you want to solve. And Definitely, that's just about the software, but the company, it's a globally operating company. We are a part of the Software AG group. Software AG is our mother company, which has been in the software business for more than 50 years. And the software is already being rolled out by leading companies in the process industry. They're already rolling out the software to all of their plants worldwide. The last thing that I also would highlight very much personally is our approach, which is centralized and around customer success. So I am also part of the customer success team at Trendminer. So we have a dedicated department just to work with our customers, to try to help our customers realize early value. So it's not a software where we just sell the software and then we just leave you alone, try to figure out to try to figure out your use cases, to try to get value. Rather, especially in the early phases, in the early phases of the project, we actually work with you together on more on a day-to-day basis to try to identify your use cases, but also to try to help you solve those use cases and to get value in as less time as possible. All right, so that was all that I had to share from the Trendminer side for today. Thank you for your attention, and if there are any questions, I'll be happy to answer them.
Thanks, Ruchika, for the nice presentation and all the three use cases that you talked about, whether it was batch analytics, whether it was continuous processing, or whether it was asset analytics. It looked as if we had gone to the factory and in the control room, we were all analyzing that particular data, and you were trying to slice and dice those data in different formats and trying to work out what went wrong during that particular process and do the rectification as soon as possible. Thank you for that. And I was also saying there was a lot of, in the Q&A window, we have around 14 questions. So we have to take up those. And everybody has appreciated your presentation. So on the behalf of all the delegates, I would like to thank you. To all the delegates, Ruchika Tawani has joined from Germany. So she's addressing us from Germany. Now I would request all the delegates to type in their questions if you have any other which have already been typed. In the meantime, I would request all the delegates to be attentive and listen to my three quiz questions that I would like to go in one shot, and so that you can answer them. And I would request all of them to please type in their answers in the chat window. I would request, please type in your answers in the chat window. My first question is, what are the two different kinds of data that Trendminer can be used with? My first question is, what are the two different kinds of data that Trendminer can be used with? The first is time series data, and what is the second? So now I go back to the second set of questions. In the demo of the root cause analysis of temperature spike, what was the reason for the reactor temperature to rise? I repeat, in the demo of the root cause analysis of temperature spike, what was the reason for the reactor temperature to rise? I'm seeing a lot of answers. In the chat window, there are around 51 of them for the two questions that we have already asked. It's a good sign that, Ruchika, that everybody is listening to your PPT very attentively.
I'm glad.
And they are replying to, and majority of the answers, I can't say anything, but everybody is typing in their answers. And my last question, which is the third one, would request everybody to be attentive, because this is the last chance to win an Amazon gift voucher. In the example of batch process analytics, which grade of batches were investigated? There are three answers. Please give the correct answer: food grade, industrial grade, or pharma grade. In the example of batch process analytics, which grade of batches were investigated? Food grade, industrial grade, or pharma grade? So Ruchika, I had a good list of questions, but when I see there are 22 questions which are there, in the Q&A, I would be the last one to ask you if I get some time. So let me go ahead with the set of questions which have already been asked by our respected delegates. And let me go one by one from the first to the last. Mr. Prasad T.L. Gupta talks about which industry sectors are being more addressed. So if you can answer, Ruchika.
Yeah. So we, as I was, I know it was a very short slide, but we do actually work with a lot of different industrial sectors. So chemicals is definitely the main one, but we also have, just to name a few, we have oil and gas, we have pulp and paper, we have energy, we have food, we have pharma. So it really, if you're looking for something specific, I think it really depends on the kind of sector that you're looking at. But we, I can say that for sure that we definitely have a present in each of the main industrial sectors that we have in the process industry.
There is an anonymous question. Are you connecting systems through API? If yes, then do you also do API management?
Okay, so in this case, I think it's a bit, the answer would be a bit dependent on which platform or which software API are we talking about. Because we, I think in general, I would say we do have the possibility to connect our system to several different softwares via APIs as well. But yeah, which software, which API, then we have to look into the specifics. So if there is a specific solution that you're interested in, then I would suggest to reach out to us, use the website, reach out to us, and then we can discuss further.
The next question is, this is also an anonymous one, how your batch software and other analytic solution can be implemented on OT systems of different makes like Yokogawa and Emerson etc.
Okay, so in this case, how we are using the data or the software is actually, we do not, so we actually gather the data from your batch analysis system. So it could be a Yokogawa or Emerson system. We gather the data from there and we work further with that data within the trend miner universe itself. So we do not, let's say, take trend miner and write back something to your Yokogawa batch system. Rather, we use the data that you already have in there and do the analytics on that data.
So Dilip Maurya is asking you, does the software also take corrective action to bring the parameter back to required value, which is a very important question. So if you can reply to that.
Yeah, I agree. It's a very important point. It's a very valid point. But Trend Miner does not, since it's not connected to the control system, it cannot take corrective actions. It can notify you of the deviations that are happening in your process, but then you as an engineer or as an operator have to take control of the process and do the corrective actions yourself. Trend Miner is not connected directly to the control logic.
There is a question for Mr. Devendra Rathore. Can you share any example for continuous process related to any oil refinery unit?
Yes, we have actually a lot of use cases in oil refineries as well. Of course, for the sake of the presentation, I could not dive deeper into each of the sectors, but I would suggest that you either get in touch with us either via the website or on LinkedIn, or there's also a lot of material related to the oil and gas sector available on our website as well. So there are also certain webinars that we have hosted specifically for the oil and gas sector. So I would also suggest taking a look in there if you're interested in specific use cases.
There is a question from Kaushal K. What is the level of awareness about data for the Indian chemical industry? How is the response from the Indian market? And how do you want to create awareness about data in the Indian chemical and petrochemical industry?
Yeah. So this is again a very broader question. I would say in general, the awareness is definitely there. So every time we interact with customers, we interact with prospects in India, they're very aware that they need to, and it's not like they're lacking in the data collection. They've already started collecting and utilizing the data, but it's not happening to that level that they would like it to happen. So the awareness is there, but the solution is, I have the feeling sometimes that the solution hasn't reached the right people yet. So they're still looking for the right solution. And yeah, on behalf of Trend Miner, I think what we are trying to do to create awareness is, for example, of course, webinars like this, but we also have a dedicated team which is responsible only for the Indian market to try to find more prospects and to try to create this awareness among people who might be looking for the solution.
Vivek Gupta has appreciated your presentation. He says with clear thoughts and quite practical as well as good for analysis. And his question is, where is this software installed, and with what scan rate data is required, and does it take data from DCS?
Yeah, so the software does not take data from DCS. Usually, the way the infrastructure is built is that you would have your DCS. From the DCS, the data would be flowing into something that's called a historian, because the problem is that the DCS typically stores data only for the last 30 days. And when we talk about data analysis, we actually talk about years and years of data that can be analyzed together. So from the DCS, there is usually a middle layer, which is called the historian. So the historian is capable of storing this data that is coming from DCS and not wiping it off after 30 days. So to accumulate this data, and TrendMiner actually sits on top of the historian to take the data from the historian and to gather basically years of data to do the analysis.
Sanjay Dodia also says a nice overview. So congrats to you for the presentation. And does, in the long run, prescriptive analytics reduce importance of human intelligence? Is it practically possible for AI and ML to take ownership and accountability as that of DCS operator in process industry?
Yeah, that's a very interesting question. I think a lot of people have very different views on this question, but I think I would say as of now, as of today, it's not that far yet that it might be able to eliminate human intelligence completely, because as I also briefly mentioned in my presentation, we have data scientists all over the world. We have people who can program, who can script and get some insights. But for them also, it's difficult to make sense of the data. So to make sense of that data, you definitely need some human element in there of the people who have been working with this process for years and years.
But do you see your next version? I was seeing the three use cases that you talked about, where one has to go into each and every and then come to a conclusion. Will it give a pop-up and say, this was the problem, and because of that, that particular batch was not up to the mark?
So it's all about setting it up at first. So what I showed was just like the initial setup, that we have this, for example, the pharma batches, which we create a fingerprint. Once you have that fingerprint created, then TrendMiner automatically takes care of that analysis part for you and says that there is a deviation and there are parameters that need to be looked at. So this is all just about setting it up at first.
Dilip Maurya is talking about, in the case of heat exchanger, the increase in cooling time could be due to some other reason, like change in the cooling fluid temperature or higher process temperature at start. How do I find this using the software?
Yeah. So when I say cooling time, of course, now it was a very to the point presentation, but when I say we calculated the cooling time, we also do take those measurements into consideration during our calculation. So for instance, you can actually calculate, for example, if you're talking about heat exchangers, you can actually, there are ways to calculate the heat exchanger coefficient itself within the software. So you can incorporate those factors by calculating the heat exchanger coefficient, for instance, and then see if the coefficient is reducing, or if there is fouling in the system.
Then Vivek Gupta is talking about the licenses for limited tags or unlimited tags.
In general, it's for unlimited tags. So we support it definitely, but also depends on the server or the system that you are putting TrendMiner on. So how much storage does it have? But in general, we do not put a limit on the number of tags that you can connect to when you first start using the system.
Mr. Dilip Maurya is talking about, can I run simulation in the software? Like, say, what will happen to the process if I increase the pressure? So what he's saying is that, can I, what we can say, go for a near perfection kind of a thing by automating the entire thing and say, this, if we are able to do this, we will be able to get an ideal batch.
So regarding simulations, it's not a process simulation tool, it's purely a data analytics tool. So in this case, now we have the newest feature where we are also able to program within the software itself. So if you are able to create those simulation models by doing some programming in Python, for instance, or in any other way that you might think of, there could be a possibility to do those simulations, but in general, it's just a tool based on analysis of the data and not on process modeling.
Anonymous attendee is talking about, can we import our own existing algorithms? If yes, what language does it support?
Yeah, so that's part of the previous answer that I was mentioning, that we have came up with a Python environment within the software itself. So using that, it might be possible to import your existing algorithms as well.
Shrija Nair is talking about how data cleaning is done and clean data to be provided to the software or raw data.
Yeah, so we actually use raw data and we do the data cleaning within the software itself. Now, in this example, I had already cleaned the data because I did not want to waste time in the webinar right now while doing this data cleaning. But we have ways to actually identify and clean the data within the software itself. So just to give you an example, you could define some certain process conditions that are normal for you, and everything that is not in these process conditions, you can directly filter out or exclude from your data.
Sanjay Ram Srija Nair has another question. LIMS data may not a lot, and also not continuous. How this is taken care to analyze along with IP21 data?
Yeah. So IP21 data is time series data, so it's continuous and it's basically measured at a very regular frequency. So that's directly your time series data, your sensor data. But LIMS data, how we handle is we try to include that into the software using this contextual information. So if you remember in the batch analytics example, I showed you that for the pharma batches, we had the measurements like the viscosity, molecular weight, color. So all of these information are coming from the LIMS system, and they do not need to be measured continuously. Rather, you just need to know for which batch or for which time period does this measurement correspond to, and then we can directly map it to your time series data.
Sanjay Ram is talking about, do you look into corrosion solutioning?
Yes, I'm pretty sure we can find some use cases that we also have done at our customers for this corrosion solutioning. But what I would do is I would maybe, if you can get in touch with me via LinkedIn or via the company website, we can talk about it in more detail, because I don't have a specific use case right now to mention.
Deepak Nath is talking about how this will be integrated with existing DCS.
Yeah, so again, it's not first thing is it's not meant to replace DCS at all. It's just meant to add another layer to your already existing infrastructure. So you have DCS. DCS would be sending the information to the historian, where you will be storing your data, and historian will send that data to TrendMan.
Pavitra Gupta talks about very informative presentation with real-time use cases. Great work, Ruchika.
Thank you.
Then Dinesh is talking about, do you work with chloro-alkali problems?
Okay, I think again, this is a very specific process, and I think we can also check that in detail in a separate call or something.
So we have some more time. Please type in your questions. I think we will answer all your queries. And Ruchika is very smart. She is, what we can say, giving very short answers so that we can take up more questions. So please feel free to ask all doubts that you do have, and we will try to answer all of them in this particular session. Hope you are okay, Ruchika.
Yeah, sure. Go ahead.
Venkatesh Siva Rachna is talking about, we have to give the root cause of problem at first time occurrence? Do we have to give the root cause of problem at first time occurrence?
No, so we do not have to give the root cause of the problem. Rather, we have to help trend miner, rather trend miner will help us to identify the root cause of the problem.
Rajesh Raut, if possible, could you provide few names of Indian customers, and does Indian chemical industry has some unique challenges for a data analytics solution?
Yeah. Regarding the Indian customers, I think unfortunately due to some contractual or legal reasons, I am not allowed to name any customers in a webinar like this. But if you, as I mentioned earlier, we have a team dedicated which is working in the Indian market. So if you would like to know more about the Indian market in general, I can definitely recommend you to reach out to us, and then we can have a conversation about the Indian market in specific. And regarding the challenges for a data analytics solution, I think the Indian chemical industry does not have any specific challenges. Rather, it's all over the world where we have our customers. We always face the same challenges, that there is a lack of data scientists. There is an immediate need to get insights from the data. There is a lack of tool. For example, I mentioned that a lot of people try to do it in Excel, but it's not really very efficient, and it's also not very user friendly to do this kind of an analysis in Excel. So it's again very common problems that we see not just in India but all over the world.
Just adding to Ruchika, Software AG has around 1,000 employees working in India, and the company has a partner network for local support. Sunil Patil is talking about, does Trend Miner connects with data historian like Aspen IP21? And do you have any example of connecting with IP21?
Yeah, so IP21 is actually one of the very standard historians that we connect to. We have a lot of our customers that connect to IP21, so that it's not a problem to connect to IP21. Apart from that, if even for the others, if anyone is interested, we connect to most of the general well-known historians like OZPI, IP21, Yokogawa, and GE, and most of the historians that you might know from the industry. I think we should be able to connect to them.
Sanjay Ram is talking about, do you have a program to train experienced people in your product and use them in projects?
Yeah, so let me just see. Yeah, so I think
people in your product and so that they can use in projects.
Yeah. So I had mentioned this briefly during my presentation towards the end, that we have a dedicated customer success team. So I'm also part of the customer success team. So our job is actually basically to do exactly the same thing that you are mentioning, that we work together with the customers to train them in the use of the software, but also not just to have it training based on, for example, these three example use cases that I presented today, but we also do our training based on the customer data itself. So the way we will be training you is, we will be looking at your data, we will be looking at your use cases, and we will be helping you to solve these use cases in Trend Miner in the best way possible.
Vivek Gupta ji is talking about, do you have India team for help, which Ruchika has already mentioned. So your response, Ruchika.
Yeah, so we do have a team, and I think at this moment, I would just say that either use the website to reach out to us, and then we can set up something for you to have a conversation with our team.
And anyway, what we will do is we will share, Vivek ji, we will share your database with the company Trend Miner, and they will always connect with you after this event. Even Sanjay Ram is asking the same question. Please share your contacts to Ruchika. But I will definitely Chemical News will share your contacts, Sanjay ji, to Ruchika. Have you worked with biological processes?
Yes, we have worked with biological processes as well. So, for example, one thing that comes directly to my mind is, for example, wastewater facilities. We have a lot of customers in the water industries, and I actually also have worked with a few of these wastewater industries in the past, and there they typically have a lot of these biological processes. So I think in general, we definitely do have use cases in that direction as well.
Vivek Gupta is talking about, what is the normal period of execution of such projects in chlor-alkali plant?
Okay,
What
so
is the
again,
normal period of execution?
yeah. So the normal period of execution, I would say it's, I think the question is about the chlor-alkali plant, but I think in general also it depends very strongly on what your particular use case is. So for example, if it's just about finding the heat exchanger fouling that we saw today, that is a matter of a few hours that you can set up something. But if it's about a bigger problem, let's say optimization of a distillation column, or about, let's say, reducing the energy consumption in your plant, so that could take a bit longer. So it really depends on what exactly the use case is, what are the needs of the process. And if you're talking about execution in the sense that how much time would it take for us to get the software, to get us started with this software, to start doing our analysis, that's usually done within a couple of weeks, I would say.
Rajesh Roth says completely understand the confidentiality, and thank you for such a nice presentation. R. Meenakshi Sundaram, any trend miner product application in an offshore oil and gas processing platform?
Yeah, again, we do have customers in the oil and gas platform. For the specifics on which customer is using the software in an offshore platform or where, that I'm unable to answer that, of course, right now. But I would also direct you to, we have a dedicated oil and gas page as well on our website. So I would also direct you that you also go and take a look over there, and then you might be able to find this information.
So we have answered all the 36 questions, 3 dozen of them. Thanks, Ruchika, for being very patient in hearing all the questions and trying to answer all of them. I have got one more, so I would also like to take that last one also.
Sure.
So if there are any other questions, please feel free to write to us, and Ruchika will try to answer all of them. Haresh Ochani, is the software specific to a problem, or it can be used throughout an operating plant from end to end?
Yeah, so it's actually a really versatile software. So in general, it can really be used from end to end, but it just depends on the kind of data that you make available to the software. So if you can if you actually have the data for the entire plant, it can definitely be used in each and every sector of the plant individually as well.
Sambhu Ranawat is talking, can your solution work for any PVC plant?
Mm-hmm. I think I cannot remember the use case right now, but I think we definitely have some customers that do have a PVC production as well, so it can be used.
So I think we have answered all our questions. Let me come back and announce the quiz winners. The first question was, what are the 2 different kinds of data that Trend Miner can be used with? The first was time series data, and the second one is contextual data. And Apeksha Tiwari from Tri-Diagonal Solutions is the winner, Apeksha Tiwari. The second question was, in the demo of the root cause analysis of temperature spike, what was the reason for the reactor temperature to rise? The answer is increase in cooling water temperature, cooling water increase. And the winner is Mr. Satyendra Joshi from Raj Industries Limited. The third question was, in the example of batch process analytics, which grade of batches were investigated? And it was a multiple choice question. Food grade, industrial grade, or pharma grade. The correct answer is pharma grade. And Muthu Bharti from Tirumalai Chemicals is the winner. So, having announced all the winners, I would request all the participants, if you can rate Ruchika's presentation on a scale of 1 to 5, 1 being the lowest and 5 being the highest. At least give your what we can say, feedback, so that she can improve upon, or if there is nothing to improve upon, then that is also very good. So she can feel happy about it.
Yes, definitely.
So I would request all delegates who are there present, if you can rate her presentation. And the best part about is he has answered all 38 questions, which was remarkable in such a short span of time. So with this, I would request all delegates to register for the next set of events. May 11, we have the Unlocking Lab Efficiency Through Digital Transformation. May 18, Indian Specialty Chemicals, Opportunities Galore. May 21, Green Chemistry and Sustainability Challenges and Opportunities. And please go to our website, Indian Chemical News, go to the e-conference session, and please register for all the above events that I talked about. Let me thank a presenting partner, TrendMiner, a software AG company. Let me also thank my speaker, Ms. Ruchika Tiwani, data analytics engineer, TrendMiner, and she has joined all the way from Germany for this e-conference. Thank you, ma'am. Let me thank all delegates who registered and also participated in this event. Those who didn't get a chance to look at our event or participate in our event, they can go to our website and look, and they can listen to the recorded session. Thanking you all. Once again, I would thank Ruchika for her presentation, for her answering all the queries. And let me thank all the delegates who registered and also participated in this event. Thank you all. Thanking you all. This is Praveen Prashant signing off, to meet again on May 11 at 2:55 Indian Standard Time. Till then, goodbye and take care, and make and see that you are all safe. Thank you. Bye.